Today we will be solving systems of equations by graphing. So first off, before you can start solving a system of equations, you need to understand what is a system of equations. A system of equations is really just two equations. And in our case, they will both be linear equations, meaning they make straight lines. To solve a system of equations, all we need to do is find the point of intersection of those two lines. In other words, we want to find the point where the two lines meet. The solution to a system is always a point, meaning a coordinate x, y. I emphasize point 3 times there because it's very important that you realize the solution to a system is a point, x, y. When we're solving a system by graphing, the first thing we need to do is graph both lines on the same coordinate plane. In order to graph a line, you want to make sure that your equation is in y equals mx plus b form, or slope-intercept form. You must use a straight edge, or you might not get the right answer. Your line should always be straight. So once you draw your two lines, then you find the point where those two lines intersect, and that's your solution. And you can check that it satisfies both equations. So, for some examples, we are going to solve each system of equations by graphing, and then I'm going to remind you how you can check those answers in the Desmos calculator. So if you don't have your Desmos calculator pulled up yet, pause this video right now, go pull up Desmos either on an internet browser, which is what I'm going to use, or on an app on your phone. I know some of you downloaded the app on your phone in class. However you want to use Desmos, you want to have it handy so that you can check your answers in Desmos and practice that. So pause the video and do that now. Okay, so what we're going to do is solve the system. So the first thing you need to do is make sure it's in slope-intercept form, or y equals mx plus b. This equation, both of these equations are in y equals mx plus b. So we can go ahead and figure out, for the first equation, the slope is 2 over 1. So the slope is 2, which we write as a fraction when we graph. The y-intercept is -3, and that's where that came from. So in order to graph, the first thing you do is you draw a point at the y-intercept, so where b is -3. So I go down to -3 on the y-axis, I draw a point there. Then for my slope, because it's positive, that means I go up 2 and right 1. Remember, slope is always rise over run. So I'm going to go up 2 spaces and right 1 space. Then I'm going to go up 2 spaces and right 1 space again. Then up 2 spaces, right 1. Remember, slope is a constant rate of change, so it keeps going over and over and over. If I want to go the opposite direction, I just go the complete opposite way. So that means down 2 spaces and left 1 space. Once you've made your points, you get your straight edge. That could be a ruler, the side of your notebook, the side of a calculator, something straight, right? Put it across those points and then make yourself a line. So there's my line. I'm going to erase those dots. Okay, so that's my first line. Now, b is -3. Sorry. So now we're going to be looking at the second equation. For that equation, the slope is -2 over 1 and the y-intercept is 1. So your slope comes from your equation. The slope is -2. That's where the -2 over 1 came from. And the y-intercept is 1. So that's where this 1 came from. So when I'm plotting my points for that one, I'm going to start at 1 on the y-axis, because that's my y-intercept, My slope is -2 over 1 this time. What that tells me is I go down 2 spaces and right 1 space. So, down 2, right 1. Down 2, right 1. Remember, it's constant, so you keep doing the same pattern. Down 2, right 1. If I want to go backwards, then I go the complete opposite direction, meaning up 2 and left 1. And that keeps it in the same line. Okay, once you have your points, you use your straight edge to draw a straight line, and you do see that these two lines intersect. They intersect right here. So that's your solution. Remember, the solution is a point. So the final answer, and make sure you do give a final answer, the final answer is 1, -1. So that is our solution, 1, -1. It's really important that you remember to write your solution. Sometimes students will draw the two lines beautifully, find where they intersect, but they never actually write down the solution. So the solution is the point where the two lines intersect. Okay, looking at number 2, same idea. The first equation is in slope-intercept form. So we can go ahead and find our slope, which is -2/3, and our y-intercept, which is 4. If I'm going to graph that equation, that means I start on the y-axis at 4. -2/3 tells me to go down 2 and right 3 spaces. So rise over run. So go down 2 spaces and right 1, 2, 3 spaces. Now, I can go down 2 and I can't quite go 3. It looks like it'd be about right there. Then use your straight edge, draw a line between those points. Okay, for the second equation, it is not in y equals mx plus b form because you have a 3 in front of your y. In order to get it into y equals mx plus b form, you would divide everything in the entire equation by 3. So divide everything in the entire equation, because remember, you want y by itself. When I do that, I get the answer, y equals 1/3 x minus 2. Because don't forget, in front of an x, if there is no number there, there's an imaginary 1. So that's where I got 1/3 x, and 6 divided by 3 gave me that 2. So now that it is in y equals mx plus b form, I can see my slope is 1/3, and my y-intercept is -2. Remember, a positive 1/3 then means I go up 1 space and right 3 spaces, rise over run. So I'm going to start at the y-intercept, -2, and then using my slope, I go up 1, right 3 spaces, up 1, right 3 spaces again. And you see these lines do intersect. Maybe. There we go. These two lines do intersect at this point right here. And that point is the point 6, 0. So that is the solution to that equation. Okay, if we go down to the bottom 2, they work much the same way. For number 3, both equations are already in y equals mx plus b form and slope-intercept form, so that's great. We can go ahead and find our slope and y-intercept. For the first equation, the slope is -1/4, and the y-intercept is -3. Remember to start with your y-intercept, -3 on the y-axis. That's right there. And then my slope is -1. So down 1, right 4. So down 1, rise over run. Down 1 and right 4. So I go down 1, right 1, 2, 3, 4 spaces. I can't go any further that direction, so if I want to make points on the other side, I do the complete opposite. So up 1, left 4. and then it's still in line. Oops. So, connecting those points with a straight edge, there's your line. For the second equation, y equals x plus 1. It is in slope-intercept form. Don't forget, if you don't have a coefficient in front of your x, that means your slope is 1. So, my slope and y-intercept for that equation, my slope is 1 over 1 because it is rise over run, and the y-intercept is also 1. Because they are both positive, that means I go up 1 space and right 1 space. So I start with my y-intercept of 1 on the y-axis. I go up 1 space, right 1 space, up 1 space, right 1 space, up 1 space, right 1 space, up 1 space, right 1 space. If I want to go backwards, I just do the complete opposite. Down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Now I connect those lines with my straight edge. And you see, these lines connect at this point right here. But if you look closely, those lines do not intersect at a whole number. That does not mean that we do not have a solution here. It just means we don't have a whole number solution. So pull up Desmos on either on your phone or on your app or wherever you use Desmos. Type your two equations into the two boxes. So the first equation was y equals negative 1/4 x minus 3. So type that in Desmos. Y equals negative 1/4 x minus 3. And then click the box down. Type the second equation, y equals x plus 1. So y equals x plus 1. And if you look at your graph, you see two lines showed up on the graph. We're looking for the point where those two lines intersect. So if you click right where the two lines intersect, a point pops up, and that is your solution. So it does have a solution, it's just not two whole numbers. The solution there is negative 3.2, comma, negative 2.2. So that is what our solution is. And that is a good review for how to type it into Desmos and get your solutions. So reminder, you type both equations into Desmos, exactly how they're written on the paper. Two lines will come up. If you don't see those two lines right away, you can move the graph all around until you find where the two lines intersect. Click the point where the two lines intersect. A point will come up and tell you exactly what the solution is. So for problem 4, the problems are not in slope-intercept form. You have x plus y equals 4 and 5y equals x minus 10. So one way to solve the problem is just like all the other ones, solve for y, which I've done here at the bottom, and then get the slope and y-intercept, graph each line, find where they intersect. If you do all of that by hand, you would get the solution 5, negative 1. However, the easier way to do that is to use the resources you have, which is Desmos. So go to Desmos, type the equations exactly how you see them. So x plus y equals 4 and 5y equals x minus 10, exactly as they're written on the paper, not after you solve for y. Then you move your graph around until you find where the two lines intersect. Click the point where they intersect, and it will tell you the solution 5, negative 1, which is exactly what we got when we solved it by hand. So this is a great resource that you can use when solving systems of equations. And this will especially come in handy when we start solving word problems on the next video.